Hello again. Do you know if you were to shrink the Earth to the size of a beach ball, the inhabitable atmosphere would be thinner than this piece of paper? This thin layer of air helps protect the Earth from dangerous radiation and interstellar space material. Understanding the Earth's atmosphere is the first step in understanding weather. It's important to understand weather and what causes weather because it is a primary factor in deciding your go, no-go decision making before each flight. And also weather is a contributing factor to some of the most hazardous flight conditions a pilot can face. Today I'm going to talk about the Earth's atmosphere, the composition of the atmosphere, atmospheric layers, and the International Standard Atmosphere. First we're going to go into the composition of the atmosphere. The atmosphere is made up of several gases that are constantly in motion. These gases have a fairly uniform property up to approximately 30 miles above the Earth's surface. If you were to capture a cubic foot of a typical atmosphere and analyze it, you would find that 21% of that is oxygen, 78% of that is nitrogen, and the remaining 1% is a combination of other gases, primarily argon and CO2. Now this cubic foot of atmosphere also has water vapor, however that varies from 0 to 5%. Because of this relatively small amount of water vapor, this is a contributing factor to changes in the weather. Next I'm going to talk about atmospheric levels. The atmosphere is broken into layers according to their characteristics. And the first one is the troposphere, which is the closest to the Earth. It is where the majority of the weather takes place. It extends from the Earth's surface to approximately 6 to 7 miles above the Earth's surface. Now it varies as far as height above the Earth's surface. At the poles it can be from 20,000 feet above the Earth's surface. At the equator it could be up to 60,000 feet above the Earth's surface, or is. And it varies with seasons. It's higher in the summer and lower in the winter. Right outside the troposphere is the tropopause. And the tropopause, that acts like a lid over the atmosphere containing most of the water vapor. So because of this, that tropopause blocks most of the water vapor, so it contains most of the weather in our atmosphere. The stratosphere has fairly the same properties as the troposphere, and once in a while you'll get maybe a cumulonimbus anvil. The top of the cloud will penetrate into the stratosphere, but it's very seldom. The stratosphere is approximately 19 to 22 miles above the Earth's surface. The remaining two levels, the mesosphere is approximately 45 to 51 miles above the Earth's surface, and then the last layer, which is the thermosphere, and they have very little influence over the weather, or no influence over the weather. Lastly, I'd like to talk about the International Standard Atmosphere. The International Standard Atmosphere is put in place to standardize temperature and pressure. This is used for certain flight instruments and performance data. At sea level, this is important, at sea level, the standard barometric pressure for the International Standard Atmosphere, here's my pen, is 29.92 inches of mercury, or 10.3.2 millibars. That's the standard pressure. The standard temperature is 15 degrees Celsius or 59 degrees Fahrenheit at sea level. So just to review, the pressure is, the International Standard Atmospheric Pressure is 2992 inches of mercury or 15 degrees Celsius at sea level. Now, because temperature and pressure change with altitude, they came up with these international standard lapse rates. Now, the international standard lapse rate for pressure decreases 1 inch of pressure every 1,000 feet. So the international pressure lapse rate is a decrease of 1 inch of pressure every 1,000 feet. Now the international temperature lapse rate is a decrease of 2 degrees Celsius every 1,000 feet. And that's basically the international standard atmosphere. Now, like I said, the pressure and temperature decrease with altitude, and temperature does as well, but temperature is a little different throughout the atmosphere. Temperature, which is an important FAA question, is what's the major change in the temperature lapse rate in the tropopause, and the answer to that is an abrupt change of temperature lapse rate. As you can see here, the lapse rate actually stops, and once it is in the stratosphere, it actually starts to climb, and then again it decreases, and then the thermosphere, it again starts to climb. So temperature acts differently throughout the atmosphere, other than pressure and density. So once again, we talked about the composition of the atmosphere. We talked about atmospheric levels, international standard atmosphere. It's very important to understand these because weather is a everyday aspect of a pilot's, and you need to understand the weather. Thank you.